All right, we're going to go over our linear regression T intervals. And again, it's important you understand these intervals are the goal is to give an estimate, a plausible range for the values of the slope of that linear relationship. So here we have this first problem about the image quality. So as our image quality is getting better in our electronics and such, is that going to then reduce the time that it takes to read a passage? So maybe there is a linear relation in part of it. I imagine it would reduce the value to a certain point, and then it's going to level out. I mean, because it's going to take you a certain amount of time to read that passage, no matter how well the quality is, how good the quality is. Okay, slope beta is the slope of the relationship between that image quality and time to read a passage. We don't know how to do the intervals or the inference conditions yet. So I did a linear regression T interval to estimate that slope. So I had that data in L1, L2, and I got this value here. That was 8 pieces of data, so my degrees of freedom was 6. So you can have either one of these interpretations. Now, I did not know what the unit was for image quality, so I used pixels because that's all I knew that to be possibly. So here would be I am 95% confident that the slope of the relationship between image quality and time to read a passage is between negative 0.623 and negative 0.082 seconds per pixel. Remember, our units are y units per x units. And our y was the time. That was the response we were measuring in relationship to the image quality in pixels or whatever that units was. I like this interpretation. I think it makes more sense to the regular person. I'm 95% confident that for every increase in pixels or whatever that unit is in image quality, then the time to read a passage is going to decrease 0.08 to 0.62 seconds. See, that's just so much, makes more common sense. So consider knowing that, even if you choose to write the other one, because your job as a statistician, an educated person from my class, is that you can communicate properly to people who don't know statistics. All right, the S in the computer printout right here is that standard deviation of the residuals. So the average amount that the actual time to read the passage varies from the predicted time to read the passage is 0.24 seconds. So seems pretty small, just a quarter of a second. All right, and then here we had this from a sample of 24 farms, this computer printout. So we have our slope, our standard deviation of the slope. The T and the P are missing, so I imagine if I was running a test, I could find those on my own. Okay, let's see here. State and interpret the standard deviation of the residuals in context. So that's this number, 1.655. The average amount that the actual crop yield varies from the predicted crop yield is 1.66 bushels. The Y unit was bushels. And then the slope. So if we sampled many times, then I'd have varying slopes. So I'd expect that slope of the relationship between the crop yield and the cost of the crop, that the cost that the crop cost to plant. So we're talking about the cost to plant it, not what we get from it. So that slope of the relationship will vary about 0.1435. That came from this number right here. And then the units are y per x. Well, the y, see, the cost is the x variable. So that's, and that's in dollars per acre. It says here in the prompt, dollars per acre. And then the y variable is bushels. So it's like 14 cents. Oh, no, it's 0.1435 bushels per dollar per acre. So there's the units there. So create a 90% confidence interval, slope of the relationship between the corn crop yield and the cost to plant the crop. And linear regression t interval, here is the formula. Sample slope plus or minus critical value times the S of B. Filled in the numbers, and there we got degrees of freedom 22 because the sample size was 24. So I am 90% confident that the true slope of the relationship between corn crop yield and corn crop cost is between 0.239 and 0.733 bushels per dollar per acre. Or you could say, I'm 90% confident that for every additional dollar per acre that the corn crop costs, the corn crop yield increases between 0.239 and 0.733 bushels. That just seems so much more real world information. I mean, that just makes so much more sense than blabbing out this formulaic response up here. Okay, multiple choice problems. So here we were asked to find the interval from this 10 randomly selected interviewers, which indicated the degree of freedom was this. Now, make sure you know that when you are doing this interval, of course, that's your sample slope plus or minus your critical value, your T star, times that standard deviation of the slope. Okay, so there's that standard deviation of the slope. And T star seems to be the thing that gets my students. Inverse T of 0.02, comma 8. Why did I use 0.02? Well, I was told to be 96% confident. If 0.96 is in the middle, then 4% is left in the tails. That makes this 0.02. So that is inverse norm of 1 tail, comma, 8 degrees of freedom. This is not the T star. That's not the critical value. This is how many standard deviations the sample slope is away from 0. Okay, so there's our answer C. Next, here was our just interpretation of the correlation. So I guess that's the correlation coefficient. That's the R. So I square rooted the R squared. So there's a strong positive linear relationship between the bear's neck girth and its weight. So this one got me because I was expecting to tell about just my experience with these kind of problems on the College Board exam. Is they will ask you about slope, and then they will ask you about the correlation. How are slope and correlation affected by the removal of this point? And so that's what I was prepared to say. I was like, oh, okay. So removing that point would make the correlation stronger. And then removing that point, so let's see. I considered this black line or gray line when this point A is removed. The blue one is with A in there. So by getting rid of this point, that slope will go back down, which toggles this and is making that y-intercept go up, which that's what this question asked about, was slope and not correlation, but y-intercept. So that y-intercept actually increases. So that caught me off guard. I actually was looking for what happens to the correlation, and then I was like, oh wait, it's asking about y-intercept. So here we go. All right, our AP tester trio threw in some way different types of problems here. So we had some savanna African elephants, and we had this particular male African elephant with a weight of 12,800. And so we were then asked, what would be the weight for a mainland Asian elephant to have the same standardized score? So that meant that I had to do x minus the mean over the standard deviation and find the z-score for that particular savanna African elephant. And then come over here and find the weight of that mainland Asian elephant, that is 1.5 standard deviations above the mean. So there it is. And here with this number 2, the question was asking to find a significant difference in their pulse rates. So that means I'm actually interested in a set of data that isn't there before or after, but I want to know how much did it change. So I just want this one average of their differences. So that's going to mean, so I have this data, it's paired by subject, so it was definitely a matched pair t-test for means. All right, and then here we have a transformation problem. So we had this situation where the pay was $300 plus $250 per car. So keep in mind that the mean is affected by plus 300 and 250 times the number of cars. But this standard deviation right here is only affected by multiplication by 250, not plus 300. So there we have our answer E. All right, that's it. And so there is your assignment 3. And now we're going to go on to the assumptions that we've been leaving off. The final topic in our Unit 10, the assumptions to be able to run these inference procedures, a test, or an interval. All right, so I'll see you in the next video.